The following is a recording of a conversation I had with Amit of Sierra Circuits. Sierra Circuits are a California-based PCB manufacturer and assembly house. Sierra Circuits very kindly agreed to answer some questions about design for manufacturing, specific aspects to PCB design as they relate to manufacturing, and I've recorded our conversation for you to watch and listen to in this video. Again, a huge thank you to Sierra Circuits, specifically to Amit and Lucy. Make sure to check out their website as well. They also have many handy tools, which I'll link in the description box below. For instance, the Better DFM tool, which is an online tool that can help check your manufacturability of your printed circuit board design. They also have many different handbooks, guides, often host webinars with PCB design experts, and also have SierraConnect, which is a forum where you can ask questions and browse through various PCB related and electronics related posts. With that being said, let's get into the various questions and the recording.
So yeah, I had this list of questions. I don't know if we can go through them if that's okay with you.
There's I saw them and they're great questions. They're very cross-functional. You know, one thing interesting about manufacturing a circuit board and doing assembly, it's actually a very cross-functional thing. And in the US, it's mainly been PCB fabricators and then assembly fabricators, and they always were separate companies, I would say. But now we see a little bit more of a consolidation. So Sierra is the same way. We build our own fabs, and that's how we started. And then we also do assembly. So questions like these are very cross-functional. Yeah, so that's
great because it's I've attended some courses also from IPC. And you always get various bits of information. So the assemblers might say this, the manufacturers and designers might say a different thing. So it'd be great to get your take on it. If you don't mind, I would also maybe share my ECAD tool Altium Designer just so we can go through the design. Maybe that would make it more visual in a way. I might also do some overlays in the video.
So I don't know how much Lucy told you about us. So we are on a mission to educate as many PCB designers as we possibly can. That's something that, you know, is central to our mission as a company.
That's great. Yeah, I really enjoyed the videos you do with Robert Ferenic, and also seen some of the webinars, at least the ones you posted on YouTube. Those were very interesting. I also actually read your DFM handbook, and I noticed there were some answers to some of these questions in there already. So just for the first questions, this is what I heard from an IPC CID Plus course relating to gasketing and stencil design. So I used to have, for example, on capacitors, well here, I used to have essentially completely squared off pads. However, the IPC CID instructor said it's better to have rounded corners on pretty much all pads because that helps with applying solder paste, stenciling, and so on. So I'd like to ask you what your opinion is on that.
I think it's a better way to do it, and you're correct. It will help with, you know, all the processes, and you know, a lot of the processes for PCB manufacturing are wet processes, and so rounded corners, you know, basically less right angles, the better, right? So yeah, I think it's a good idea, both for the fab side as well as for the assembly side.
Okay, so you pretty much go with all rounded corners. Is there a particular corner radius? You say the rounder the better, so as far as you can get away with surface area, that's how you then round the corners. Okay, that's great. Okay, good. One thing that also I think also with beginners is the solder mask expansions. So some people say, for example, the solder mask layers, you should just leave no solder mask expansion, let the manufacturer, for example, edit the solder mask around the pads. For example, with components such as like a QFN package, where you have very closely spaced pads, very fine pitch, sometimes what I'll do is, because I like to define my own solder mask expansion, that might be wrong with me, is to then create, for example, a solder mask opening throughout the whole pad. So that essentially there's no slivers, which might not be able to be manufactured anyway, left over. So what would you recommend designers do for that?
Yeah, so I recommend you follow the manufacturer's guidelines for solder mask. So for example, for us, we like a 4 mil solder mask web, and we can go less, right? It depends on the design. So it depends how much copper, it depends, you know, what surface finish, those things do matter, but I would always recommend to have a solder mask web if your manufacturer can support that, because that's going to be better for assembly regardless.
Yes, okay, so that's what I try to do, exactly. Just if I can maintain that minimum web width, for example, this design and this manufacturer, this was possible, but for some maybe solder mask colors that might not be, and then I do, for example, maybe a fill and then get rid essentially of those webs. Is that a good practice, or should I just essentially reduce the solder mask to be just the outline of a pad and let the manufacturer, so to speak, deal with it?
I think so. I think that the designer should be aware of the manufacturing rules around solder mask. And you mentioned color, that also is an impact, right? Because different colors expose differently and have different processing parameters. But I would leave it 1-to-1 with the pad, even knowing what the manufacturing tolerances are. Because then that signals the manufacturer that, you're okay with them editing your mask. If you have an area that you don't want the manufacturer to touch on the mask, then I would create your solder mask for that component or footprint, and then I would say, don't change the solder mask for this.
Okay, so you would selectively do that and then have the designer add notes, specific areas to say don't touch here and so on. Okay. Another very common question is, for example, something along the line of acid traps. For example, if you maybe have some odd entries, and maybe I can't do it exactly here, into the pads, that you can maybe get these acute angles, these triangular shapes. Is that still a problem? I mean, I try to maintain proper entries, so vertical or horizontal, or if needs be 45 degrees into a pad. But are acid traps a thing?
They are a thing. Again, manufacturing is a wet process. So, I have a virtual tour of our factory I can show you, but basically the develop, etch, and strip line is a horizontal, for us, it's a horizontal line, and you have spray nozzles that come down. It's a wet process. And, acid traps are real. And, if you have the ability to teardrop or, again, remove as many 90-degree angles as possible, I would do it.
Okay, so even intersections like so, where we have these sharp, so to speak, 90-degree angles, that could even be a problem.
I mean, problem is a very big word. I would say better design practice is to teardrop. Yeah, and
okay.
Can an acid trap actually cause a problem? Well, the answer is yes, but maybe your designs wouldn't, fall into that category, and you don't have to worry about it. But we have absolutely seen acid traps cause an issue before.
Okay, and what kind of issues did you see?
Yeah, so what you're talking about, you could end up having slivers. You could have a neck down in an area that you don't want. It could impact your signal integrity. All these types of those things can happen. At the end of the day, the customer is sending us a design, and it's not going to be 100% exact what is being manufactured, because I'll give you an example of Etch Comp, right? So we'll take this trace and pad and we'll add Etch Comp to it, which basically means that we know that when we go through our etching process, we're going to etch away a little bit more copper, and it's going to go back down to what the designer is looking for. So it's a wet process and a variable process. It's not exactly what you see on your screen is what we're going to build.
Okay, so in terms of teardrops, then would that be that the fab house does that, or preferably, or would the designer in the design tool add teardrops?
Yeah, I think whatever's easier. In this case, I would say just add a note on your fab drawing. I hope people have fab drawings, but fab drawing basically says, add teardrops, okay to add teardrops, and then that gives the manufacturer a license to do that.
Okay, great. And you do that both for S&D and through hole?
Yeah.
There's of course the whole electrical standpoint to it, to filling essentially unused space, so to speak, with copper fills, applying that to a certain net, whatever. But from a manufacturing standpoint, there's always the copper balance aspect as well.
Right.
I don't know if there's any rules of thumbs or when this might become a concern, copper balance. For example, how unbalanced across the board stack does it have to be, or is this even still a concern? From what board sizes might this be a concern? Maybe it's hard to say as a general answer.
Copper percentage does matter per layer. Even today, there was a very complex board that we were building, and the customer said, we sent this board to another fabricator and it came out warped. And what are you doing different, right? Well, that's a hard answer. But one thing that we do and should be common practice among fabricators is to add a lot of thieving around the image, so not impacting the design of the designers. So as you build your boards on a sheet, right, we consider the copper area of the whole sheet, and we try and balance as much copper as we can on the whole sheet. But if you have, as a designer, an opportunity to put copper pour, I would follow the design guidelines of the manufacturer and do that. More copper, the better. There's more copper to adhere to in lamination to help prevent delam. It's a balanced construction, so we can, any PCB manufacturer can, process the inner layers better, without, I'll give you an example. Like, it's an extreme example, but let's say you had a 3 mil core, and on one side you have 1 ounce of copper, and it's like a ground pour, and on the other side it's a signal layer, and there's just very few signals and not much copper. That inner layer core would have the tendency to curl up, and if something's curling up on you, you got to take measures to counter that. It's not standard. You could have cracks. All these types of issues can happen. So balancing your copper is a real thing, both on different layers in your stack up as well as on that layer, and knowing what is the core. So what is this layer, and then what's the opposing side of that core? What does that copper weight look like? And copper.
Okay, great. Okay, thank you. Yeah, from a manufacturing perspective, that definitely makes sense. Just as a designer with copper pours is essentially always the cleanup of the copper pour. So it's easy to just draw a polygon, but then you might have little islands that maybe aren't connected, or with the years it might be difficult to get in there. And that's the only trade-off I see for me, and also maybe impedance effects around that you have to do proper clearances and so on. Okay, but for manufacturing, you would say pretty much all the time you should aim for that. Yeah,
do copper pour, and honestly, the CAM softwares that we have right now are very powerful, so they can handle, like a nice optimization or cleanup. So you could leave some of that to us, a fabricator. Just, I would say, ask for your Gerbers back for approval. If you have a sensitive impedance area or RF area, you should, I think it's good practice, ask for your Gerbers back for approval to make sure that, that there's no extraneous copper where you don't want it, and,
Okay, no, that's a great idea. So the next one would be about annular rings and annular ring capabilities. So the only, at least what I've seen so far, only place I've seen other than, for example, the IPC CID courses is, for example, EuroCircuits, when you drill a bit higher or a larger diameter, and then you plate down to the final hole diameter. So actually, the annular ring calculation should include, for example, a larger drill bit, and then you divide by 2 to get the annular ring. But most manufacturers won't state that, or most calculations won't tell you about that. At least from what I've seen. That might be completely wrong. So should annular ring calculations, I assume, should also take in the larger drill size for plating?
So so that goes back to, how do you want to do things? Do you want to own the design completely? Do you want to lean on your manufacturer, follow their design guides a little bit, ask them, talk to them? Because if you're building a standard product, then what EuroCircuits said is fine. Standard copper weight, standard surface finishes, maybe ENIG, things like that. But when you get outside of the standard, then it's really important to talk to your fabricator. So for example, I'll give you a couple examples. The way you described it is correct. We're going to drill bigger than what the finished hole size requirement is. So on your fab drawing, you should always specify the finished hole size, and you should specify tolerance. And so we are going to drill bigger than the finished hole size. Now, what about the copper weight? Because as you plate on the surface, you also plate in the hole. So if there's a little bit more thickness of copper that we're finishing at, like 2 ounces, then that changes the drill size that we're going to use. So we're going to make it a little bit bigger, so that as the copper gets plated on the surface, it also plates in the hole, and we can handle that, based on the overall finished copper weight. So starting copper, finished copper weights play a role into what is the drill size that's going to be used to actually drill your hole. So you have to be careful with how do you decide, how you want to calculate annular ring. I personally think it should be, finished hole size plus whatever your fabricator says it should be.
Okay, no, that makes sense. Yeah, I just find it peculiar that usually that's not talked about, and the only places I've seen it are, for example, on IPC, CID, or that EuroCircuit side.
Well, I don't think it's talked about because every manufacturer has their different rules of thumbs. But again, for a standard product, considering that we're going to pick the next drill size that can accommodate, maybe IPC requirements of copper in the via. So 8/10 is the minimum requirement. So if you can think, okay, this is my finished hole size, plus I need to drill it, plus I need to add 8/10 of copper, what would be the drill size at that point? That's how we kind of figure it out. And then if the surface finish is like a hassle, that takes up a lot of, that's very thick. And so different from ENIG, which is an electroless process. So a hassle surface finish would make us drill even higher. So these are the considerations. So it's not necessarily just cut and dry. It's up to the fabricator and what they've seen their processes and processes tolerances result in.
Okay, oh, great. That makes sense. What's often a problem when I'm, for example, footprint position files, component placement files, also when you're already defining or creating your own libraries for the footprints, defining essentially what is the base component orientation. Now it seems wherever, for example, whatever manufacturer you go with, they might have different standards, at least from what I've seen, where they define, let's say, where north is, or rotations and so on. How should your, for example, component libraries be defined by? How do you define orientations, so to speak, properly?
For orientations, there isn't necessarily any one standard. So I think that's the issue that you're referring to. But, I would say that whatever you do, just be consistent. I don't know. That would be kind of like my generic answer on that. I guess you could follow IPC guidelines as well. But there's really no one way of doing that.
Okay, so there isn't, for example, a standard for pick and place machines that manufacturers or assemblers might use that rotate the component or have an orientation, a default orientation, where, for example, 0 degrees is? There isn't something like that.
You can do 0 degrees, but the pick and place machine doesn't really care.
Okay.
Yeah. If you're going to standardize on something, then just standardize on 0 degrees. But it's really not, it's not a thing.
Okay. So essentially the component placement files, the pick and place files, are probably always edited by the assembler beforehand.
It's a good idea that you mentioned to, make sure that the 0 rotation in the footprint corresponds to the feed direction for the component that's in the reel. But that's something that we take into account.
Okay. And I think the next question is something I actually saw in your DFM guide. So I'm sometimes wondering, for example, with having different drill sizes, so might have 0.15, 0.3, or at least finished diameter hole sizes. Is there any cost difference or any benefit in reducing the number of drill sizes? So just sticking with only 0.25. Sometimes I guess they'll get rounded as well to the nearest drill bit or whatever you then plate to. Is there any benefit of reducing?
Yeah. So my perspective is that of a prototype manufacturer, someone who is doing, lots of different part numbers per day and not that many. But if you're, in the consumer market and you're doing millions of pieces or tens of thousands of pieces, I would say that there is a benefit in that scenario. But in a prototype environment, or even in like a few hundred or 1,000 pieces, it doesn't really matter. Yeah, what you're saving on is the time it takes for a drill machine to go and drop a drill and pick up another drill. And then, our machines these days, they'll pick up the drill, they'll measure the size of the drill, make sure that's accurate before it starts drilling. So you're saving on the, that type of a timeline, just dropping and picking of a drill bit. But other than that, there's really no impact. And nowadays our drill machines have these big canisters at the back of the drill machine. So when there's a job that we're loading onto the machine, literally the tooling is done automatically because all the drills and all the sizes and all the variations are built within the machine. So there's really no kind of pre-set up extra charge, and there's really no cost benefit to minimize the number of drill sizes, but in production it might make an impact.
Okay, no, that's great to know. Okay, so the next question would be related, for example, to fiducial markers. So normally I would just do a round exposed pad and then pull back the solder mask opening. I did, however, steal this maybe from NVIDIA. I noticed on their graphics cards they use more of these cross fiducial markers. Is there any manufacturing or assembly preference to what size or what shape fiducial marker is used?
I think so. Over the years, our best practice for fiducials is to have, 3 sides be round and then one side be a square. And that's really just so that we know the orientation, and you're not getting the orientation wrong when you're putting that into an assembly machine.
Okay, so actually having, so you said 3 round, 1 square, it's actually 4 fiducial markers on the PCB. Does this cross? I mean, I've seen that on some NVIDIA, and I think it might have been, it's just an optical thing rather than having any use.
Yeah, it's just someone's
preference.
Just
giving. I thought it looked quite cool, so I guess that's the only thing.
A lot of designers do things that look cool, so that's fine.
Okay, good. All right. In terms of, next thing would be, for example, rounding drill hole sizes. So sometimes, especially if, for example, in Europe, we're working with metric, we might get a US data sheet that has mil specifications for the drills, and then underneath they'll have rounded it a drill for maybe to 1.02 millimeters. I typically would then round up, taking into account, of course, tolerances and so on. But how would you maybe go about something like that?
I think that I'm going to go back to kind of just a generic answer. Understand that the tolerances for your fabricator are, and usually very normal, it's plus or minus 3 mils on a finished via. For a non-plated via, we can do a tighter tolerance of the hole because there's no plating in there. So that when you drill a hole, you're removing probably 0.5 mil. And then, so if someone says, I can do a non-plated through hole plus or minus 2 mils, well, you can do it even tighter than that, because when you drill the via, it really only removes about 0.5 mil. So, in terms of rounding, you can round up, you can round down, just understand the tolerances of the drill, I think.
So the next question would be actually polarity markings. There's, of course, many ways of marking the polarity. One indicators, it could be lines or dots or anything. Is there anything that assembly lines or assemblers prefer? For example, marking the cathode or marking the anode and what shape that is? Or is that an odd question?
No, it's not an odd question. I think it's a very important question. So, we have a DFA guide, and that's like the number one DFA issue. So, if you're, I think, having the actual symbol, is the best thing to do, frankly speaking. You do a plus or an A for the anode, that's fine, and a K or C for the cathode, but having the symbol also is the best thing.
One point that I also oftentimes get uncommon, because normally I don't place, for example, component designators on silkscreen. To me, it's more of annoyance, so to speak, trying to fit things in. And usually for denser boards, you're going to have to produce the text size that's hardly legible anyway. Other than, unless you're, of course, doing prototypes and manual assembly, but for actual automated assembly, do designators on silkscreen add anything? Or as long as you have a good assembly drawing, is that pretty much all you need?
No, I would say component designators are essential. It prevents errors. And again, I live in the prototype world where there's literally hundreds of errors on every design that we get, right? So we're constantly giving the feedback and correcting those issues. And then, you have manufacturing, which, is still requires labor. There's humans involved in making circuit boards. So having, proper silkscreen, having proper component designators in silkscreen, I think is a critical thing that you shouldn't skip. If the design is version number 5 and revision 5, and it's now in mass production, a mass production house might have a different answer, right? Nothing's changing. And nothing should change. So they might have a different answer, but from a development standpoint, which is what we do, is work with people early on in their design phase, there's always issues and there's always errors. So I think that that's a critical thing to have.
Okay, no, that definitely makes sense. I was just reminded of it because when I was doing an IPC CID course, essentially the instructor told us, maybe very opinionated, that not useless, but there could be problems, for example, that silkscreen that is too close to exposed copper, and that could maybe overlap, and then you get assembly issues, and arguing that way. But you say, I mean, yes, for the prototyping, it makes sense to add in the designators, and that's less of an issue than, for example, silkscreen registration, alignment, and so on.
Yeah, so again, designers should know their manufacturing tolerances, right? So you should have it, and you should follow the guidelines of the manufacturer. What are the tolerances, and what sizes you should use so that it's legible. And there's in our front end department, we clip the silk screen. So if a silk screen is falling on too close to something, let's say too close to a pad, we will clip it. So you won't have that issue of silk-treating too close to a copper pad or something, but because we're going to clip it, but then it now becomes useless for assembly. So, follow the guidelines so that after the fabricator, is done with their optimizations of your data, that it's still useful for the AOI machines at assembly.
Okay. Topic of creating one's own panels as a designer, is that something manufacturers even want, for example, designers to do? To me, I would have thought that manufacturers would want to arrange on a panel, depends maybe on volume or if they're putting it together on a sheet or a panel with other designs. What are your thoughts on that?
As a practice at Sierra, we haven't, we basically design our own panels. The customers, aren't really, we don't leave that as a burden on the customers anymore. And there's a couple of reasons for that. So first of all, there's the optimization on a full sheet on the PCB side. And then there's also optimization in assembly. So you have to balance those two optimizations. I don't think a designer has all the information to make the best educated decisions. So for example, I'll give you a quick example. So in rigid flex PCB manufacturing, to do an array really eats up a lot of real estate on a sheet. You need lots of spacing between parts. Sometimes fabricators will nest rigid flex boards, things like that, so they're not losing too much real estate. But regardless, doing a one-up and routing out the single-up rigid flex board is more optimal space utilization for the fabrication side. Now, on the assembly side, you probably have to say, okay, well, assembling one board at a time is not optimal. Now, in that case, maybe the assembly will make a decision that we are going to generate a fixture, properly hold the board the way we want to in assembly. You're basically, if you optimize the PCB sheet and get the lowest cost PCB, you could be then increasing costs on the assembly side and vice versa. So you have to make the decision, you have to make a holistic decision. And that's not the only thing that goes into making an array. I mean, it's utilization. It's also, do you have any components that are overhanging in your array design and are boards spaced apart, properly apart? But, so all those go into that decision process. So basically, we don't want our customers trying to make those decisions because we end up correcting it anyway. So we basically do that for our customers. But in terms of general guidelines for creating an array, there are some, of course, right? But look out for, overhanging components too close to the edge, et cetera. And I would say that, other common things in building your array, I would say is, make sure you have railings so that if you're going to build an array, your assembly shop needs to hold on to the railings. I would say there's going to be some guidelines around building arrays.
For example, layer indices in copper. So I will typically add, for example, just in copper, just etched away, so it's an index of the layer, which I think might be a useful thing. Probably not necessary, but are there similar things that could be beneficial that the designer can do that maybe makes the manufacturer's life a tiny bit easier?
So that trick I've seen a long time ago. It's like a really old trick, and I think it's great. On our sheet, we do the same thing. So we basically have these mechanical mechanisms so that we can't get the layer order wrong, we can't get the orientation wrong. All those things come into play on our sheets. So you don't really need it on the board anymore. But it's nice, it's cute, and I think it doesn't hurt anything. And then I think that other than that, there's really nothing like that on a fabricator side that we absolutely need or want. I think the most important thing, in my opinion, for a designer is to have a fabrication drawing and to properly communicate anything special or what they're looking for. From the fabricator. A fabrication drawing is universal and, is key to building a board to specification. So that's what I would recommend, is actually having a fabrication drawing more than anything else. And then in terms of we talked about copper pores, and if you have any keep out areas, that's important to outline in the Gerbers. A lot of fabricators will put their logo and date code, right where they see an empty spot. And sometimes designers want that area to be free of any copper. If you want like a keep out, you should specify that on a Gerber layer. So these things are fab drawings or Gerber layers. I think communicating anything special is key in that way.
And in terms of fab drawings, do you prefer that if we're going with Gerber format, be a separate Gerber layer, or would you rather, for example, a PDF or any other form of documentation to document that?
I think you should, as a designer, put it in your Gerbers and send a PDF, both.
Fabrication notes, fabrication drawings. So I guess every designer or company has their own set or way of doing that. Is there maybe a template that people could use, or maybe that Sierra prefers in terms of which order or what the notes are? Is there something like that available?
Yeah, no, yes, we definitely have our standard notes that we would, I can send it to you if you want, or we can send you a link to it basically. But yeah, we do have standard notes. Every designer should have a fab drawing, and they should have those standard notes on the drawing. Yep.
Okay, because I have my standard, which is a template as well, but that's kind of pieced together from repetition and finding out what works, what doesn't, and then having a standard set, which might not be ideal. So yeah, if you have a link to that, that would be great. Thank you. I've heard quite a lot that the manufacturer does actually edit, for example, the fab files quite a bit, of course, to compensate maybe for some warp or shrinkage or whatever the right term is. I guess the designer will have no influence over that, or is there anything that the designer could do to aid the manufacturer and make that less of a painless process?
Just understand that when we add Etch Comp, now we have to etch through smaller spacing. So in manufacturing a circuit board, it's the spacing between features that's the most difficult to deal with as a manufacturer. So if, let's say you had an option with a trace and space situation to have more spacing and a smaller trace, that's the design decision I would make as a designer, and that would help your fabricator to be able to build your board.
For example, Gerber, ODB++, or for example, IC format, is there any preference? I mean, Gerber seems to be the old standard that hasn't really been surpassed too much yet. As a manufacturer, what file format do you prefer?
Yeah, so we prefer ODB, and that being said, if you send Gerber and ODB, you can say use Gerber for the fab and ODB for assembly. But in order to properly do flying probe test after assembly, and to program the assembly machines, you really need ODB data. And then there's the new format, IPC 2581. More and more fabricators are supporting that format, and I'm a full proponent of that format because it helps designers not get anything wrong. It's basically one package. It includes stack ups, it includes your bill of material, it includes everything. So really understanding what needs to go in the package will be a thing of the past with the 2581. And it also includes a bi-directional component to it. So if we bring in your data and we want to make a comment on a feature design that you've done, we could literally make a comment and send it back to you, and you can import it back into your designer's tool. So there's a lot of advantages of 2581. So first and foremost, I'm a proponent of 2581, but we live in today, and not every fabricator is going to support 2581. So I would say go with ODB. And if you have a problem with just ODB and you want to use Gerbers for your fab, then say use Gerbers for fab and ODB for assembly. And that works too.
Okay. Is the majority of files you get still Gerber, or what kind of proportions do you get these days?
We get about 50% ODB, which is huge compared to where it used to be 5 years ago. And we still get Gerber, so the other 50% is Gerber. And so, yeah, we're getting both at this point.
So it's the last question, if that's okay. So, for example, for signal integrity and other reasons normally, and also having less voiding in, for example, fills and inner layers, usually I would remove unused pad shapes, for example, from vias or plated through holes, and typically leave, for example, start and end layer pads. Is there any problem with, for example, removing maybe start and end layers or outer layer pads and just having, for example, one inner layer pad or a number of them? Or is there anything from a manufacturing standpoint that could go wrong?
First of all, I would always remove non-functional pads. And that would be a fab note saying to the fabricator, hey, it's okay to remove non-functional pads. Especially if it's a heavy copper type of a situation, when the drill is going through your board, it gets deflected by all that copper. So you have to do things like slow down your drills So they're spinning slower and feeding slower, and you might have to do a flip drill where you drill from one side, then you flip the board over and drill again from the other side. So better to remove non-functional pads, and it'll minimize deflection. And then as per, whether, you should, if you could have a pad on any layer, yeah, go ahead. That doesn't
Okay, so outer layer pads we can also remove if they're not needed. Okay,
Yeah.
Okay, all right.
Yeah.
Again, a huge thank you to Amit and Lucy from Sierra Circuits for taking the time to answer these questions, and I hope these answers and the discussion we had proves to be useful for your own PCB designs. Again, links to Sierra Circuits and their very, very handy tools and guides will be in the description box below. Thanks again for watching this video, and I hope to see you in the next one. Bye-bye.